how would you go about explaining causality in three levels of difficulty? Now, this is inspired by the Wired, the YouTube series. So there are three levels, right? One is the grandma level, then there is the college fresher level, and the third is the causal expert level. So if you can explain causality to all these three people, how would you go about it?
Yeah, that's a good one. There's so for like my grandma, that's actually a real scenario because she's always interested in what I do, but yeah, obviously she does not have the knowledge to understand me like most people in my family that are not mathematicians. But um, yeah, I think causality, the way I would explain it is very simple, right? Is if I do something, what happens? I think that's one way of understanding causality at a very basic level. So um, humans, we understand it very intuitively, right? If I tell my grandma, well, grandma, look, when you put your egg on the frying pan, it will cook, but only if you put some heat, right? And so the heat is causing the egg to cook. If there was no heat, the egg would not cook. So that is like very basic causality that we are understand very intuitively. And then when you move up to a more nuanced understanding, this is for a college fresher. So let's say that they are pretty curious and they like to think a bit more. I would already be comfortable talking about a counterfactual, right? So if my egg cooked, I can imagine what would have happened in an alternative world where I didn't put the heat. Well, it's pretty easy to understand that the egg would not cook. But when we get to more complex problems, like we give drugs to patients, it is a lot more complicated, right? So if I have a headache, okay, you can ask what caused my headache. Then you see like, okay, maybe it's because I drink too much coffee. Okay, so then you can think, okay, maybe in an alternative world I did not drink so much coffee, so I am not suffering from withdrawal symptoms. So then you can say, okay, maybe the coffee is causing the headache. Or you can say, okay, now I have a headache, I take a pill. Um, okay, now I feel better. But okay, in an alternative world, if I didn't take the pill, maybe I would still feel better because my headache just went away because I drank water or I took a nap or something. So as soon as we get to a little things a little bit more complex, less controlled, it's very difficult to understand like what is really causing the effects I see. So a lot of scientists they're super interested in that, and it turns out that well you have to use data, but then you get stuck because you never see the counterfactual world, right? You can never take a person and not give them the pill and give them the pill at the same time. That is not possible. So you need at least two people, but then these people are different. So then all this brings complications, and that's why it's a whole area of study that is both methodological but also very philosophical in a sense. And for a causal expert, I mean, maybe I wouldn't have much to explain to them because they are experts, but I would explain that, at least in the modern sense of causality, there is a few ways to understand it. So there is this counterfactual world approach where you try to simulate how to have data that could represent what would have happened in the counterfactual world. And there's different ways to do this, right? So the randomized control trial, that is a way to do it. You, because of randomization, you get these counterfactual treatment and control groups that you can use to kind of infer what would have happened in the population if I had not given them the drug. And this is why you are able to detect causal effects within statistical error. So you also have statistical uncertainty that comes from just the nature of having limited data and things like that. Um, and you can also look at it more in Pearl's point of view, where you have these systems of interacting variables, and you do interventions in the system, and this changes how the system behaves. And you can study the distribution of the variables under the intervention. And if you are clever enough and your system, you have a good model for your system, it turns out that you do not need to actually perform the intervention. You can just observe the system and infer some causality in certain cases just from observing the system. But in other cases, you need to actually perform the intervention to see what would happen. So I think that would be the three levels. I hope that it was good for my grandma, especially. I hope she understands what I tried to tell her.